Good evening. Mm, Good evening. I hope I'm audible and visible. So, welcome to today's session. Today will be the last week of the problem solving sessions for this course. And today we'll be discussing problems or questions related to lectures 55 to 60. Your 12th assignment is due tomorrow. And along with this, we'll be also roughly going through revision points of lectures involved in week 1 to week 6. You will also be having an extra session next Tuesday, and then during that time I'll be discussing about the revision points from week 7 to week 12. Okay, so we'll move to the 12th week's questions. The first question is, which one of the following caused global warming? A very simple, and this chapter is basically involves impacts of climate change on water resources. So, and all these are very generic um, stuff that is there in these lecture in the last few lectures. It will be quite easy for all of you to answer. So you can post in your answers in the chat box, right? So, carbon dioxide is that which causes global warming. So let's see what global warming is. I'm sure everyone of you must be knowing it, but then let's just again refresh your uh, knowledge about this. So global warming is basically a gradual increase in the Earth's temperature due to greenhouse effect. Now, greenhouse effect is an effect that is necessary to maintain the temperature of the Earth. But what happens is because of excessive usage of fossil fuels and vehicles and uh, a lot of causes that is resulting in the increase of greenhouse gases like carbon dioxide, CFCs, and other pollutants. What happens is the amount the surplus increase of greenhouse gases in the atmosphere is resulting in the earth be warmed up more than it is necessary. So greenhouse effect is not a negative effect, it is something that keeps our earth's temperature stable so that it makes life possible on earth. But when there's excessive exploitation of various human related activities that results in the increase in greenhouse gases like carbon dioxide, methane, CFCs, water vapor, all of this will result in the excessive warming of the earth, and this process is called global warming. Now, some of the greenhouse gases, carbon dioxide is a greenhouse gas that is contributing excessively to this global warming effect. Along with that, there are fluorinated gases like hydrofluorocarbons, perfluorocarbons, and sulfur hexafluorocarbon fluorides. Then there are these are some of the properties related to those fluorinated gases. They are emitted into the atmosphere due to high usage of electronic items. Then methane is another greenhouse gas that is resulting as a result of excessive dairy farming and other agricultural practices that release in the excess amount of methane into the atmosphere. Nitrous oxide is another greenhouse gas. So the answer for this question would be option A, carbon dioxide. Oxygen, nitrogen, and hydrogen are not greenhouse gases. Moving on, which one of the following results take place due to global warming? Right? Out of the options provided, uh, s- mm, due to greenhouse, if the greenhouse effect was in a stable level, then global warming won't occur and the steady temperature will be maintained in the earth. Similarly, environment under as a result of global warming, the environment is not at all pleasant now. There is excessive summers, I mean heat during the summers, and also the rainfall pattern has completely changed from the uh, routine I mean routine patterns, and pollution is also exceeding as a result of excessive human activities. So changes in rainfall is one result as a result of global warming. So the answer B will be correct. Again, let's see, look into how these precipitation changes, what are the precipitation changes or rainfall changes that are occurring. So as the temperature warms, the rate at which the water is evaporating from water bodies as well as soil is going to increase. So the amount of water vapor that is going to be present in the atmosphere is going to be higher. Since there is a lot of atmospheric pressure, the uh, this moisture should come down onto the come down onto the earth's surface in the form of rain. Now, how is this changing? Is because excessive heating is resulting in excessive evaporation, which is going to result in excessive rainfall, that too occurring at very in a very erratic pattern, not in the usual way that is generally predicted for a region. So the correct answer is changes in rainfall. Next question: which one of the following is the effect of global warming on water resources? Okay. So let's see the altogether what are the impacts on water resources. So as a result of global warming, there is an overall increase in the temperature of water in the water bodies like oceans, rivers, etc. Then again, we talked about how the rainfall patterns are changing. There's high intensity and extreme rainfall in very erratic patterns. There is also a result of sea level increase, rise in the sea level because of the excessive melting of the polar ice caps. And then there is another process called ocean acidification, which is basically the water of the oceans consists of a lot of salts and minerals, and there is a change or there is chemical and physical changes, modification occurring in the mineral composition of the oceans because of the absorption of the carbon dioxide from the atmosphere. Also, as a result of temperature increase of the waters in the bodies of the ocean. So, what happens when the air and the water temperature increases? This will result, I mean, air temperature increasing is eventually resulting in the water temperature to increase, and this is going to impact a lot of uh, habitats in the oceans. Particularly, you must have heard about how these coral reefs are getting extinct because they are very sensitive to even minute changes in temperature. So, as a result of which, reefs are deteriorating at a very high rate. So, that is one consequence of temperature changes to the water in oceans. Precipitation changes, we we talked about it because of the high content of moisture in the atmosphere, extreme rainfalls as well as erratic patterns of rainfall, and sometimes there is no rainfall at all. So all these are the impact of precipitation changes on water resources. This is not only going to the rainfall pattern is in turn going to impact the water demand, water supply, the quality of water, all of those. Water available, like I said, water availability. Now, if we are supposed to get the particular amount of rainfall in a particular period, and lack of rainfall during that period is going to result in water shortage. In the same way, if there's excessive amount of rainfall occurring, like extreme rainfalls occurring, then that is again going to result in events like floods. So this is and floods are such that it is going to flow off as runoff excessively, and there is no storage of water in the earth. There is no subsurface infiltration because the rate of rainfall will be very much higher than the infiltration rate, due to which the soil is not able to accumulate water, which will in turn replenish groundwater. So that is groundwater depletion is also going to occur. And there are a lot of consequences of flooding and droughts. So these are the results, these are the consequences of changes in precipitation, water quality, and water quantity. Even water quality is going to change, because when large amounts of water is being flowing through the surface and going off as flood, this is going to take away all the this is going to impact the soil fertility. Not only fertility, it is going to wash off all the fertilizers in agricultural land and going to pollute the water bodies. So this will also result in problems like erosion and pollution of water bodies. Then storms, increase in intensity of storms. This will produce, again, this is going to impact water resources either directly or indirectly. Then sea level rise, when the water of the level of the sea water rises, this is going to result in problems like seawater intrusion, as well as lands going to subside because of this increasing level of water. The coastal areas are going to subside, and there are studies that have shown that uh, in uh, in a couple of decades, a lot of land is going to go underwater because of this rise in sea level. Particularly wetlands, deltas, coastal plains, mangrove forests, all of these are going to be highly impacted by sea level rise. All of this is coming under that. Then ocean acidification. Ocean acidification is basically the absorption of carbon dioxide by oceans are going to result in this process called ocean acidification. This water is going to mix with carbon dioxide to form carbonic acid, and this is going to result in the impact a lot of aquatic habitats. So, one of the impact of global warming out of these options would be ocean acidification. Fourth question, is the weather the same as climate? Is the statement true or false? Correct. Weather and climate are two different things. Weather is the daily forecast or daily levels of variables that we are finding. What is the temperature today, or the temperature for a week, or the temperature for a month is what you call as weather. Now, climate is the weather averaged over an extended period of time, typically for 30 years and all. And when we say climate change, it is not something that it's not something we talk about over the variation in the weather parameters of a month or 2 months or even a year. It is something that is as a consequence or as a result of a large period of years, which is resulting in climate uh, climate change, that is harmful impacts of climate change. So weather is not the same as climate, so the statement is false. What is the greenhouse effect out of these four options? Correct, it is the rise in the surface temperature on Earth. We talked about it. So greenhouse effect, what is greenhouse effect? Is the absorption, the retaining of greenhouse gases like carbon dioxide, water vapor, nitrous oxides, methane. All of these are actually contributing in a way to maintain the temperature of the Earth so that life is possible in Earth. If there's no greenhouse effect, then all of the water is going to become ice and life will be not possible on it. So greenhouse effect is a natural process. Excessive amount of greenhouse gases is going to result in excessive temperature increase, which is global warming. So the correct answer is option B, rise in surface temperature on Earth. Sixth question. In arid and semi-arid areas, the dependency on groundwater for water supply is between what percentage? So let me just move on to the explanation because this is a statistic. I don't think so. Um, you'll be familiar unless you go through the material. So, arid regions are regions that, by definition, receive precipitation less than 25 centimeters. And semi-arid regions are regions that receives 25 centimeters of rain per year. And semi-arid regions are regions that receive only 25 to 50 centimeter of rainfall per year. Now, groundwater is because of this, a lot of arid and semi-arid regions are dependent on groundwater resources as a means for domestic purposes as well as for irrigation. Now, if you see the statistics over here in this region, 40% of the world's food is produced by groundwater irrigated farming. In semi-arid and that is when you globally when you look at the dependency on groundwater, in arid and semi-arid regions the ground dependency on groundwater supply is between 60 to 100 percentage. So you can see here 40 percentage of the food is obtained from irrigation and cultivations that is done with the help of groundwater. And in arid and semi-arid regions alone, around 60 to 100 percentage is dependent on groundwater. So the answer for this question would be 60 to 100 percentage. If they are asking about a global scale, then the answer would be around 40 percentage of the dependency, 40 percentage dependency on groundwater for irrigation. Okay, moving on. Just a second. So this is the question. What is the concentration of carbon dioxide in the atmosphere? How much, what is the range in the variation of carbon dioxide concentration in the atmosphere from a pre-industrial value to the 2000 year 2005? We are only talking about the year 2005 because your lecture series is only talking about the ranges that is submitted in the 2005 report of IPCC. So that's why this question. So do you know the concentration of carbon dioxide right now in the atmosphere? You can maybe Google or something and let me know. I mean, I think that is some kind of information that you need to know because considering global warming is such a major issue and considering carbon dioxide is one of the major contributors to this global warming. The concentration of carbon dioxide in the atmosphere right now, 2023, 2000, okay, that's very less. Actually, the carbon dioxide concentration has increased from 280 in the pre-industrial era to around 375 ppm in 2005. So this would option C would be the right answer. But at present, in I think in terms of 2023 and 2024, the concentration of carbon dioxide is 420 ppm, which is a very high amount. And you can see how the this one is increasing. It is actually going to increase at an exponential rate. No, not yeah, slightly exponential rate. Next question. Methane is a methane is dash times more potent a greenhouse gas than carbon dioxide. Again, this is something that you might not be knowing, so I'll move on. So what we're talking here is about potency of a greenhouse gas. Now, what is this? What does it mean when you say that this gas is this many times more potent than carbon dioxide is? Now, carbon dioxide is considered as a standard greenhouse gas. So, whatever other greenhouse gases are available, they are compared to carbon dioxide. As carbon dioxide will be the reference, the value of carbon dioxide will be the reference for comparison of all the other greenhouse gases. Now, what value are we talking about is the capability or the ability of this greenhouse gas to absorb energy and slowing the rate at which the energy is escaping to space. This is what is called as global warming potential of a greenhouse gas. So, global warming potential is nothing but what is a global warming potential of carbon dioxide is considered as 1. So, in that case, what is going to be the global warming potential of other gases like methane, nitrous oxide, CFCs, HFCs is what we are talking about when we say that this gas is this many times potent than carbon dioxide. So basically, what is the potency is the ability of this gas to absorb the energy and slow down how much of energy is escaping to Earth. Like they call the radiative efficiency and the lifetime of a the existence of how long this gas is, how long is it going to stay in the atmosphere is another factor that defines the global warming potential of a greenhouse gas. Now, gases like methane, it is yeah, nitrous oxide you see here is 310 times more potent than carbon dioxide, and it will stay for around 120 years in the atmosphere. Question is, methane is how many times more potent than greenhouse gas? Methane is 21 times more potent than carbon dioxide. I am not very sure about the lifespan of it. It is not given in here. Here, these are some of the see sulfur hexafluoride at 23,900 times more potent than carbon dioxide, and it stays for a very, very long time in the atmosphere. Similarly, HFCs are this times more potent than carbon dioxide. These many times more potent than carbon dioxide and has got a lifespan of 1 to 260 years. Then there are fluorinated gases. They're not talking about the potency. So this is what we call, this is what we mean when we say that a particular greenhouse gas is more potent than carbon dioxide, and methane is 21 times more potent than carbon dioxide. I think the highest is this HFCs, hydrofluorocarbons, no, sulfur hexafluoride. Then there is hydrofluorocarbons. Then there is nitrous oxide, methane. Methane is comparatively less harmful in comparison to the other greenhouse gases. Now, which one of these following greenhouse gases is the most abundant in the atmosphere? Okay. So all of these four are greenhouse gases: carbon dioxide, methane, nitrous oxide, and water vapor. The most abundant greenhouse gas in the atmosphere is water vapor. More than any of the greenhouse gas, water vapor is what is resulting, is the most huge amounts of water vapor is present in the atmosphere. Although this is not what is contributing to the excessive amount of heat, carbon dioxide is the one which contributes the most to heating process. What percentage of irrigated produce in India comes from groundwater irrigation? Earlier, we had looked into how arid and semi-arid regions all over the world is dependent on groundwater. Here, the question is about India. So let's look at the answer. So in rural areas, around 80% of the domestic needs are fulfilled by groundwater, and in urban areas, around 50% of the domestic needs are fulfilled by groundwater. All over India, 70 to 80 percentage of the irrigated produce is coming as a result of groundwater irrigation. Also, you can see two more statistic: two-fifths of India's agricultural output is contributed from areas irrigated by groundwater. These are all statistics that can come from this portion. Moving on, so the correct answer would be option D, 70 to 80%. 11th question: what is the projected climate change for the winter precipitation will dash during the December-February period, implying greater water stress? So December-February period is the winter time. So what will happen to the precipitation in the future because of the climate change is what the question is about. So, what is projected climate change? It is nothing but we now know what is we historically we know how the pattern of rainfall has been, and we also know in the last 10 or 20 years how the pattern has been. So, based on all these historical data, we develop models or methods or equations to predict what will be the rainfall or what will be the amount of precipitation pattern in the future. So this is what is the predicted condition due to projected climate change. So here, as a result of projected climate change, all reports show that increase in temperature, which is resulting in a decrease in the winter precipitation, basically during the winter time, December, February. This will result in greater water stress during the winter periods. Again, intense rain is going to occur only in a few days. That is, the amount of rainfall that you receive, that you're supposed to receive over a month, will come down as precipitation in very few days, which is going to result in floods. So flood frequency is also going to increase. That is during the monsoon season. So here, yeah, this is resulting reduced groundwater recharging potential. So during the winter season, the rainfall is going to decrease even more than what we are receiving right now. This is going to lead to drought conditions during that period of time. So it is decreases. Option B. What can result in reduced groundwater recharge potential? Is it intense rain occurring over a few days, less rain occurring over a few days, precipitation occurring over an extended period, or none of the above? So we just discussed right now, intense rain, that is whatever rain that is supposed to occur over a lengthy period of time, if it occurs in a short period of time, what happens is the intensity with which this rainfall is happening will be much higher than the usual intensity. Because of this, but the soil infiltration rate is not going to change. That is going to be based on the type of soil. And say it has a very less infiltration capacity, the rate with which the water is entering will be much less than the rate with which the water is flowing off. So all of the water is going to go off as runoff, and the groundwater is not going to be recharged because infiltration is going to be less. So extreme rainfall or very high intensity rainfall. High intensity is nothing but when, say, instead 10 mm of rainfall occurring in 1 hour or one day, or 10 centimeters of rainfall, that is high intensity. When the rate mm per duration increases, then we say it is high intensity. When the depth of rainfall occurring over a duration is less, then we say it is a low intensity. So intense rain occurring over a few days is what is going to result in reduced groundwater recharge potential. Which out of the following are the projected climate change impact on water resources in India for the next century? We talked about the seasonal impact of climate change. What is going to be the overall impact on water resources in the next century? So, impact of water resources during the next century in India, there is going to be high increase in monsoonal and annual runoff in the central plains. There is not going to be much change in the winter runoff. We are not talking about the precipitation, but runoff is not going to change much. Then there will be increase in evaporation, and there will be increase in soil moisture during monsoon. Then in Orissa and West Bengal alone, there's going to be 1 meter sea level rise. Then Indian coastlines, again 1 meter sea level rise. All over India, there's going to be an increase in the potential evaporation. So I think all of the increased potential evaporation is going to occur. 1 meter sea level rise is going to occur in Indian coastlines, and there is no much change going to be there in the runoff of during occurring during winter. Which mitigation strategy can help reduce the effects of climate change? Mitigation is nothing but methods to reduce or methods to reduce the effects of climate change. Correct. It is promoting afforestation and carbon dioxide sequestration. So, afforestation is again, yeah, the opposite of deforestation. We are going to increase the amount of area under forest by planting forests or increasing the number of forests. Carbon sequestration is nothing but the rate with which the carbon dioxide from the atmosphere is brought back into the soil. That is what is called as carbon sequestration. Now, plants are going to use carbon dioxide for photosynthesis and making food. And this is going to result in the generation of plants, and plants, as a result, is actually consuming the carbon dioxide in the atmosphere. This is going to help in a huge reduction in the carbon dioxide content in the atmosphere. So this is why if we cut down more trees, the carbon absorption is going to reduce because plants are not going to be there to absorb carbon dioxide. The industrial activities, a lot of it result in carbon dioxide emissions. Along with that, burning fossil fuel is also a major source of carbon dioxide emission source. Now, question 14. Okay. Okay, I already provided the option here. So, how does climate change affect precipitation pattern? It is going to increase the dry periods and more intense rainfall. We had looked into this earlier. Moderate the changes. Global warming is going to result in huge amount of water vapor available in the atmosphere. This is going to result in increased intensity of rainfall, and dry periods also will be there. So option C here would be the right answer in this question. I'll modify this slide and I'll be publishing it in the sheet. Next, which gas is responsible for ocean acidification? We talked about what ocean acidification is and what is basically ocean acidification. Okay, so ocean acidification is nothing but the absorption of carbon dioxide by the oceans, and this is going to change the carbon dioxide into carbonic acid, which is going to acidify the waters in the oceans. This is ocean acidification, and its root major cause is the absorption of carbon dioxide. So, carbon dioxide gas is responsible for ocean acidification. How does rising sea level affect coastal wetlands? How does the increase in the sea levels in the coastal areas impact coastal wetlands? Does it increase the erosion rate, decrease the salinity levels, enhance coastal biodiversity, or help preserve coral reefs? Correct? The correct answer is increase erosion rates. So water is going to encroach into the land, and they're going to result in movement of fertile soils along the coastlines. So the correct answer is option A. Which out of this is not a greenhouse gas? Correct answer, it is oxygen. Carbon dioxide, methane, and nitrous oxides are greenhouse gases. What is climate? Is it the daily weather conditions, or is it weather averaged over an extended period of time? Seasonal changes in temperature or changes in atmospheric pressure? Correct answer, it is weather averaged over an extended period of time. So option B will be the right answer. What is the main driver of global warming and climate change? Is it increased solar activity, deforestation, greenhouse gas emissions, or ocean currents? Correct answer, it is greenhouse gas emissions. We had talked about this several times during this session. Now, which regions are at the highest risk of freshwater supply due to climate change? So, the tropical rainforests are those rainforests, they get a lot of rain. Are they the arid and semi-arid developing countries? We talked about arid regions being those regions that get precipitation that is less than 25 centimeters per year, and semi-arid 25 to 50 centimeter per year. Or is it the polar regions, or are the mountainous regions going to be impacted by the fresh water supply due to climate change. Correct answer. So we talked how arid and semi-arid regions are 60 to 100 percentage dependent on groundwater. So due to climate change, these situations of highly intense rainfall is going to result in a reduced groundwater recharge. And not only that, there will be long spells of dry periods resulting in a lot of drought conditions also. So these regions are the most susceptible ones to the impact, susceptible to the impact of climate change. Now, which of the following is a result of global warming? Sea level, proper sea level maintenance, proper rainfall, desertification, or afforestation? Correct answer. Desertification is nothing but when more and more regions are coming under well, coming under dry, becoming dry, then this process is desertification. Increase in the number of deserts, and that is mainly because there is unavailability of water. When water is unavailable, plants are unavailable, and when plants are unavailable, this is going to impact all of the biodiversity, animals, insects, birds. Human inhabitation becomes difficult, so this is going to result in that region being deserted. So now we'll be moving on to the revision of the first 6 weeks lectures. What is important? What going through few questions that we had done during the problem solving sessions. So before I go into that, we'll take a 5 minutes break. The time is 6:43 now. So we'll be back by 6:48, and then we'll start with this revision session. Uh, there are some general questions that usually come. I think start with the easiest numerical problems and then go on. I mean, focus on easy problems like the equations that are involved in Darcy's law. Um, and then again, there are permeable questions on discharge. Voice very good. Hello, am I audible now? Okay, so there are some easy numericals like Darcy's equation, then about how to find the discharge rate. All of such simple numericals, you might want to focus on such simple numericals. We can't say how many numericals will come in the question paper. There are some typical questions like this Darcy's questions that involve Darcy's equation is one. Then questions that involve the water budget equation is another one. So all of these, you can actually focus on all of these. Mm, Let me see. Next class, I will probably uh, consolidate a list of uh, portions from where numericals are coming based on the difficulty level. Which ones are easier to do and which ones are the ones which are more difficult. So on that basis, you can prepare. Okay, so let's just go through these revision points. So in the first week, questions of this form. What is the average annual per capita water availability in India? These are questions that can come based on the statistics in what is the average annual per capita, what is per capita water availability, what is the water availability for urban areas, what is the water availability for rural areas. These are some portions that are covered in the first week's lecture. Uh, what is the suggested benchmark for urban water supply in India according to the Ministry of Housing and Urban Affairs? Uh, just now we saw 55 liters. Is it 100 liters, 180 liters, or 135 liters? Maybe you can answer this question right now itself because we just went through this problem. In urban areas, what is the water supply? Is a question. Okay, 55 liters and 135 liters. 55 liters is for, we just now went through this portion. This is a statistic that you need to know this quantity. 135 liters is for urban areas and 55 liters per capita is for, per capita per day is for rural areas. So 55 and 135 are two numbers that you always have to have in mind. These and all are something that you will have to by heart, irrespective of there is no other way other than that. Again, if it is difficult for you to remember all these numbers, you can prioritize this less and focus on more equation based or you know what to say technical information. Now, this is another portion that we had discussed, the what is hydrological cycle and what are the different phases in hydrological cycle. There is atmospheric phase and terrestrial phase. What is the atmospheric phase? This atmospheric phase is the liquid, solid, and water vapor occurring in the form of rain, snow, and evaporated water. Then in the terrestrial phase, it is the surface and subsurface elements of hydrological cycle. That is runoff, stream flow, infiltration, percolation, groundwater flow. All of these are coming under the terrestrial phase. Rainfall, evaporation is in the atmospheric phase. So the points to focus in this portion will be what is surface runoff, what is surface detention, what is depression storage, what is infiltration, what is the difference between infiltration and percolation. All of these topics are something that you can go through when you're revising. So again, another important point is what will happen when the rate of rainfall is greater than the rate of infiltration, and the other way around when the rate of rainfall is less than the rate of infiltration. So when the rate of rainfall is greater than rate of infiltration, the water that is going into the surface, rate of infiltration is less. So say if the rate of rainfall is 10 mm per day and rate of infiltration is only 5 mm per day, only 5 mm is going to go into the soil. Remaining everything is going to go as runoff. In the same case, if the rate of rainfall is less than rate of infiltration, then all of the water is going to be taken up by the soil. So those two, the link between this rate of rainfall, intensity of rainfall, and rate of infiltration is very important. Similarly, what is the difference between rate of infiltration and infiltration capacity is another thing that you can focus on. Then again, these are again this first chapter involves a lot of numbers in from this report and that report. Like I said, if it is difficult for you to remember these values, prioritize this less and go on to more of technical information like what is hydrological cycle, the components of hydrological cycle, what is the link between all of those are technical information. So you can maybe if it is difficult, you can skip all these portions. Percentage of water that is used in irrigation. All these are, information that is very, these are things that you have to keep in mind. I don't think so there's an easy way into learning these. This is another very important question. Like Hanumanta, you had asked about problems. Focus on this area. I think definitely one problem will come asking you the rainfall is given, the evaporation is given, what will be the runoff? Questions of that sort. So what is water budget equation and the formula for water budget equation? And then again, the next portion would be what is the percentage of fresh water available in the earth. That is, how much percentage is the oceans, how much percentage is fresh water. In fresh water it is itself, what kind of fresh water sources mostly abundantly available? Is it groundwater or is it glaciers? What amount of percentage of surface water is available? What is the percentage? This one diagram is something that you need to keep in mind. This will be very good. Then what are the sources of groundwater? Like there are springs, all of that are sources of groundwater. Sources of surface water is rainfall, runoff, all of these are sources. This distribution of global water surface. And then here are two types of problems that can come. This is the problem that I was talking about. Seepage loss is given, evaporation. These two are outflow components. So using the water budget equation, which is nothing but inflow minus outflow is equal to change in storage, you can calculate what the change in storage is. The questions of this format is, I think, pretty sure to come. So you have to know what are the inflow components, what are the outflow. Inflow is nothing but whatever is coming into the earth. So rain, for example, is something that is coming from the atmosphere into the earth. So that is an inflow component. Seepage loss, in that word itself, it is a loss. So it is going out. Evaporation is also going out. So those are all outflow components. So when you subtract outflow from inflow, you will get what is the change in storage. So that is, I think, one sure short question that can come. So you can do the problems of this format from the first weeks. Then there is also this one. This is also based on the the water budget equation. Only thing they are saying that they're giving us the area and they're giving us the inflow and the outflow rate. So we have to they're giving us a volume and then they're giving the rate. So we have to convert it into volume and then find out what the answer. So inflow rate is over here. They have given 3 hours. So if you multiply this value with 3 hours, you will get what is the volume of inflow and what is volume of outflow. That volume, that inflow minus outflow volume will give us the change in storage. Now here in this question, what they have said is initially the amount of water is this. Finally, what is going to be the amount of water? So the answer that you get by subtracting outflow from inflow should be equal to the final minus initial storage. So these are problems, very typical problems that will come. Maximum that is going to happen is the value is going to change. So if you figure out how to do these two kinds of problems in the week one, I think the numerical part of uh, this week one will be covered. Apart from that, what is hydrology? What are hydrological components? Uh, Water budget equation, very important, and the distribution of global water surfaces. All of these would be some key points in week one that you can focus on. Now, moving on to the second week, the definite part of the second week is what is aquifer, acutard, aclude, and aquifuge. You have to figure out some way to know what is the difference between all these four components. Aquifer is a formation that can store as well as transmit water. When you say store, means it can store water in it. Transmitting water is water can be extracted from that very easily, or water can flow through it very easily. That is what when you say that it can transmit water or it can yield water. All of these are implying that the movement of water is can be done very it's very significant in aquifer. But in the same way, acutard is a formation where it can store ample water, but this movement is not very significant. Similarly, aclude is a formation where it can store water but no transmitting water. Aquifuge is something that cannot store neither transmit water. So what are the examples for aquifer, acutard, aclude, and aquifuge? This portion is a very important one. Definitely one or two questions can come from this portion. I think more can come from this portion. So be sure to learn this. Then again, there are questions like the questions based on this aquifer. What is the free surface of confined aquifer? What is the pressure of confined unconfined aquifer? All of these questions. What is the difference between confined and unconfined aquifer? All of these are some portions that you really need to focus on. Then comes the properties of aquifer, like specific yield and specific retention. You need to know the specific yield, specific retention, because I think this is a portion that is being repeated in the next week's lecture series also. So what is porosity? What is specific yield? What is specific retention? All these terms are things that you have to remember. The physical meaning of these terms as well as the equations that those are associated with specific yield and specific retention. So questions like these can come. What is specific yield? Giving a bunch of options, and then correct expression for specific yield, specific retention, porosity. These three formulas you have to know. Then again, examples of all these geological formation, which I talked about already. Then another important part in the second week is the geologic, apart from the aquifer and other geological formation, what are the different types of rocks, they are examples. Igneous, sedimentary, metamorphic. What are examples of igneous rocks, sedimentary rocks, metamorphic rocks? Then another one is what are consolidated formations, semi-consolidated and unconsolidated. And here, mm, also, what is the boundary between what do you call the boundary between a saturated and unsaturated layer in the subsurface? All of these are some important topics that are covered in the second week's lecture. Moving on to the third week's revision points. The questions will be mostly based on this Vado zone. That is the segregation of the Vado zone. So Vado zone is also called as the zone of aeration or unsaturated zone. And in Vado zone itself, there are three different zones. That is soil water zone, intermediate Vado zone, and capillary fringe. And after that, below that is what you find the zone of saturation, which is basically the confined aquifer, or where you will find the water table. So the saturated zone and unsaturated layer is separated by this water table. So questions of this form, which is holding water that is available to plant roots, it is the soil moisture zone. Then which zone is responsible for filtering precipitated water? It is the Vado zone. Please make sure you don't get confused with other options. So you should uh, for sure know what the soil water is, what is intermediate Vado zone, what is capillary fringe, what is groundwater zone or phreatic zone or zone of saturation, all of the differences also be sure of it. And all these terms, so it can come as what is the saturated zone in the Vado zone can be asked. So this zone, the saturated zone in Vado zone is the soil water zone. This first layer. This first layer, initially the first layer gets fully saturated with water, and then only water starts moving into the lower layers. But if they ask you which is the zone of saturation, it is going to be this layer. So be uh, careful about all of these classifications of the layers, and be thorough with all of them. Then different types of water available. There's capillary water, gravitational, hygroscopic water. All these, what is hygroscopic water? Water that cannot be extracted because it is attracted by, it is held on to the particles by the molecular attraction of these particles. So this water will not flow off as gravity, or neither can it be taken up by plants, or neither will it be evaporated. Capillary water, again the water that is rising from the water table as a result of the action of capillarity. Gravitational water, that is flowing down as a result of gravity. So what are these three types of water is one question. Then another very important portion is the Darcy's equation. What is the Darcy's equation? This is the Darcy's equation. This is another numerical portion that you can focus on. Very simple. You have to just know three things. What is hydraulic gradient, and what is hydraulic conductivity, and the Darcy's equation. This, a variation of this is, you will have the discharge, that is Q is equal to K into I into A. That variation also, if you study, one numerical is sure shot from that portion. So hydraulic gradient is nothing but delta H by delta L, and hydraulic conductivity is nothing but permeability, coefficient of permeability. What will be the units of these two quantities? This quantity is dimensionless, and this one is going to be meter per day, or meter per second, or meter per year, or whatever, in the units of velocity. So from that, you will be asked to find the velocity of groundwater. If they ask you to find the discharge, then you have to multiply this equation with A. Then you will get the discharge. So that is one short question that can come. So you can focus on this numerical in this week's lecture. Then what is permeability? These terms: hydraulic conductivity, hydraulic gradient, permeability. What is Darcy's equation? These four topics. If you make sure that you learn this, then I think a couple of questions, maybe 3 or 4 questions, probably might 3 questions might come from this. And this numerical is, I think, a short one. Yeah, this is what I was talking about. Here we are finding the velocity. Here we are finding out the discharge rate. So what is happening in that velocity equation? You're going to multiply it with one area term, then you will get the discharge. One very important thing that you have to remember is to uh, always verify the units. In the question, they'll be giving you some unit. Answer, they'll be asking you some other unit. So always be careful that you do the proper unit conversions and then find out the answer. And don't blindly just write down the values and find the answer. So those are the focus points in the third week's lecture series. In the fourth week's lecture series, it is going to be this potentiometric surface. What is piezometric or potentiometric surface? What is flowing artesian wells? What are artesian wells? And what is the top level of an unconfined aquifer? And what do you call this level of the confined aquifer? So all these definitions are something that you very necessarily need to learn in this portion. Another, again, area of focus is using these empirical formulas for finding out the groundwater recharge. So this is another numerical that can come. Unfortunately, you will have to by heart the equations if you want to attempt these numericals, because these are empirical equations, and not only the equations, the units also that is comprising of this equations. So there's Bhattacharya, Krishna Rao, Chaturvedi, Segar, Radhakrishna, Datta et al. So I don't know how, I mean, do go through all this problem solving sessions, questions, and as well as the questions that has been given in the lecture series. also your assignments. Just do the problems in these three. I think you might get a hold of 2 to 3 equations, and mainly that equation might only come. I'm not giving you a guarantee, but at least you can learn all these equations that are used in the which were discussed during this problem solving session in the lecture series and in your assignments. So these focus on problems from these three sources. So again, like I said, potentiometric and piezometric surfaces. That is the what is that? What are artesian well? What is flowing artesian well? What will be the pressure of water in a confined and unconfined aquifer? What are perennial streams, intermittent streams, ephemeral streams? Perennial streams are streams that flow throughout the year. Ephemeral, they flow for more than 30 days. Intermittent is when they flow for less than 30 days. Then effluent and influent streams, ones that provide water to the streams, and streams that provide water to the groundwater are influent streams, and streams that are obtaining water from the groundwater are called effluent streams. So these are some focus areas in fourth week's lecture. In the fifth week, uh, properties of aquifer, confined, unconfined aquifer. Again, we are going from the second, it's an extension of the second week's lecture. What is porosity, specific retention, effective porosity, aquifer thickness. So these are four properties, four options that are asking, the question is basically which is not a property. So here in the lecture, they have provided what are the aquifer parameters or aquifer properties, what it is, hydrogeological factors which are governing the storage and fluid transmitting capability of an aquifer is called the aquifer property. So porosity is one important factor. The specific retention is, effective porosity is, specific yield is. What are these? Physical meaning, definitions of it, as well as the mathematical expressions of it is important. If you're not learning anything, at least please learn this part. Porosity, retention, yield, effective porosity, as well as permeability. Then this is another important concept, transmissibility and permeability and the relationship between them. So T is equal to K into D. Transmissibility or transmissivity is equal to coefficient of permeability into the thickness of the aquifer or depth of the aquifer. Now, this is what is the definition and what is the unit, the dimension of this. This is one question that had come in the assignments. So you can go through these portions. Also, what is the physical meaning of it? So what happens when the hydraulic conductivity, that is permeability, increases and thickness reduces? Or what happens when the thickness increases and hydraulic conductivity decreases? How is the transmissivity affected? Some things that you can relate to it. But when you understand the concept, obviously you can understand the relation, the variation of these parameters. Again, the what is the coefficient of permeability indicate. Now we know that permeable, the more easily the water can flow, the more permeable it is. So coarse grained soils are highly permeable. At the same time, clay is very less permeable soil. So clayey soil is one soil which has less permeability. Gravelly soil has high permeability. Sandy soil may be a little less than gravelly, but it is also having high permeability. Then again, storage coefficient. What is storage coefficient? Storage coefficient is also called storativity. It is the volume of water that is yielded per area per unit per unit drop of water. So when it comes to unconfined aquifer, when the water table reduces or increases by 1 meter or 1 centimeter, then that volume of water that you receive per unit area is called as storage coefficient or storativity. In confined aquifer, the water is enclosed between two layers. So there is no water table. It will be at high pressure. So when there's a pressure difference, piezometric surface difference in confined aquifer, then you call it a storage coefficient of unconfined aquifer. Now you see here, if you compare the definition of storativity and storage coefficient with that of specific yield for unconfined aquifer, it will be the same. So storage coefficient or storativity is equal to specific yield for unconfined aquifer. It is called storage coefficient in case of confined aquifer. Now, what is porosity? Whether it is referring, what does it depend on? The shape of the particle, sorting, percentage of pore space in a material. It is basically the percentage of pore space in a material. What is, if you know what is porosity, also understand porosity, void ratio, relationship between that. N is equal to E by 1 plus E, and E is equal to N by 1 minus N. So the relationship between the two, what are the what are the factors on which porosity depends? Then what are the values of bulk modulus of compression? Not very important, but then yes, if you can study, do study. Then this is another very important numerical portion that is sure to come. Finding out the transmissivity. They'll give very simple numerical. They'll give you the thickness and the hydraulic conductivity. Just multiply, you will get the transmissivity. So this is another sure shot numerical that can come. Then this is also possible numerical that can come. Although I don't think. I mean, if you're able to learn, it is good. Otherwise, maybe you don't have. You just understand what is this relationship. If you understand this relationship, you will be able to derive the uh, E and N relationship also. Then yes, questions like this based on this relationship N equal to E by 1 plus E. Then what is effective porosity? Effective porosity is also called kinematic porosity. So that name also keep in mind. Then there's one portion that we didn't cover during a problem solving session is the types of permeability: absolute permeability, effective permeability, relative permeability, and the averaging techniques of permeability. There is a numerical that has been talked about in the lecture series. We know in mathematics what is averaging using arithmetic technique, harmonic technique, and geometric technique. So if you see in if the flow is horizontal, then you have to find out the average permeability by multiplying the permeability of each layer with the depth of it, and then dividing by the sum of the thicknesses. But say if the flow is vertical, sorry, if the flow is horizontal in here, if the flow is happening in this direction, then you calculate the average permeability in this way. That is H1, H2, H3 are the thickness, K1, K2, K3 are the permeabilities. Now suppose you have random flow, then you have to use the geometric method to calculate the permeability. So what is permeability and permeability? How does permeability change with different types of material? Then factors affecting permeability, the mathematical representation and the problems that are associated with it. Permeability, the dependency of permeability, types of permeability, we just now checked, and the averaging techniques. What is transmissivity? What is its definition, unit, relationship, and problems? For sure, transmissivity problem will come. There is intrinsic permeability portion also that has been covered in the 5th week's lecture. And again, storativity and storage coefficient. So that was about the 5th week. The 6th week is fully on Darcy's law. What is Darcy's law? For what kind of flow Darcy's law is valid? What are the assumptions of Darcy's law? And also the concept of Reynolds number. These 4 things are something that you need to focus on the 6th week's lesson. These are the assumptions of Darcy's law, that flow can only occur to, Darcy's law is valid only for saturated flow, laminar flow, continuous and steady flow, and the total cross-sectional area of the soil has to be considered when you're applying the Darcy's law. So questions like this can come. What is the Darcy's law valid for what kind of flow? Then another portion is the traveling time of water and actual velocity of tracer. These numericals from these 2 portions are also something that can come for sure shot. Question like this: if the traveling distance between 2 wells is this much, and if the travel time is this much, what is the velocity? Just divide the distance by time, you'll get the answer. Always keep in mind the units. This is something that can get you in trouble if you don't focus on. Then what are the factors affecting permeability? From this, if you know this equation, you can very well know what are the factors on which permeability depends. It depends on the size of the particle. It depends upon the property of the fluid that is flowing through it, that is water. It depends on the porosity or void ratio also. Then what is this Reynolds number? What is the mathematical expression for Reynolds number? And inertial force by viscous force, what is the definition? And also this expression. This is will be good to know this. Another concept is these. What is seepage? What is actual velocity or seepage velocity? So actual velocity is when you take the entire cross-sectional area into consideration. Seepage velocity is when you take only the small area. So what happens is when you divide the actual velocity by the porosity, you will get seepage velocity. Physically, it means this. How much of what is the velocity of flow happening to this when it passes through this much cross-sectional area of pores. Then what is the permeability for different types of soil? This is easy to learn. Again, if it's something that you need to keep in mind, figure out a way to keep in mind. Then another important portion is what is pressure energy, elevation energy, dynamic head or velocity head, and the relationship, this equation. What is energy? V square by 2g. This is velocity head, pressure head, elevation head. So questions like giving these expressions can come. Also, in case of groundwater, the hydraulic head is more important. Often there's no velocity head because velocity of water flow through ground in groundwater is very less. So we neglect that, and this quantity is in combinedly called as the hydraulic head. And questions related to this is a sure shot, like using the this is on based on Darcy's equation. So yeah, this is another based on the traveling time of water. This is based on intrinsic or specific permeability, the formula for it, and the units also. Darcy is the unit for permeability. So how it's the unit conversion? This will be good if you keep in mind. So here water movement, what is hydraulic head, pressure head, kinetic head, datum head, what are the factors affecting permeability, what is velocity, actual velocity, seepage velocity, travel time of tracer, actual value of tracer, the formulas and problems. This portion is where problems can come. Darcy's law is again very important, the assumption and the validity. Then there are empirical formulas for groundwater velocity. Also confined, unconfined aquifer problems to find discharge using values of, I didn't say, I mean, explain drawdown. What is the radius of influence, drawdown, height of the water in well, problems related to that. So that will be for this week. Next week again we'll focus on I'll be going through the major points involved in the 7th to 12th lectures, and also time permits we'll be going through randomly chosen problems. So it will be a sort of revision for all of you. So yeah, today's session, that's it. Thank you for attending today's session. If you have any doubts, you can ask or you're free to leave the session. Thank you, Hanumanta.